Alright, so I think this is recording. Let's take a look here at this number 7. Now, it is quadratic in form. I know that when I look at this, I'm going to be able to factor it using the X method, but I'm going to see how far I can get with just synthetic division, and then show you that I can factor it in case you want to see that solution as well. So the first thing I'm going to do is look and say, hey, this is in standard form because 4, 2, and the constant term, the exponents are in descending order. I want to look at the factors of my constant term. I want to look at the factors of 27, and that's plus or minus 1, 3, 9, and 27. I'm fortunate that the leading coefficient is 1. It makes the problem a little bit easier. And I have plus or minus 1. So I can generate a list of possible x-intercepts, possible rational x-intercepts. And that list, I take 1 and divide it by 1. I take 3 because these are my possible numerators from the constant term, from the leading coefficient. This is the possible denominators. And I'm just creating fractions, but I'm reducing my fractions. 3 over 1 reduces to 3, 9 over 1, 27 over 1. And remember, it's actually plus or minus each one of these numbers. So now I need to do synthetic division, or you know, I could plug in the numbers and see whether or not, like I can plug in 1 and quickly see that 1 minus 12 plus 27 is not 0. I can quickly plug in negative 1 and see the same thing. I can by inspection see that 1 and negative 1 are not going to give me zeros. A little bit harder for 3. So I'm going to, because 3 to the 4th is 81 and 3 squared is 9 and 9 times 12 is like 108 or something like that. The arithmetic, I'm just afraid that I'm so bad at mental arithmetic I could make a mistake. So I'm going to come in and do this one synthetic division. I've got 1x to the 4th term. I don't have any x cubed term, so I need a 0. I have an x squared term. I don't have an x term. And I have a constant term. And with these remaining numbers, can I find a 0? It may not exist, but if it does exist, then I'm going to be able to factor this. And I suspect it will because I can see that it factors, so I know I'm going to be able to find it. I just have to search hard enough to do that. So I found it right off the bat. I got lucky with the first one that I tried. Alright, so so this equation on the left, I can factor it. This 3 in factored form is x minus 3. Since this is x to the 4th, after the synthetic division it starts x to the 3rd, so that's 1x to the 3rd, 3x squared, minus 3x minus 9 is equal to 0. So, like I say, some people may be able to see that you can factor this by grouping, but I'm going to return to my list, and this time I'm not interested in the factors of 27. Now my constant term here is negative 9. So I know that generates plus or minus 1, 3, and 9. See, my list didn't get bigger. In fact, I lost the 27. 27 doesn't divide 9. And now because the leading coefficient is still 1, then this list for what I've highlighted here is just plus or minus 1, 3, and 9. And I get fortunate that I already tried 1 and negative 1 and saw that they didn't factor the original one. So 1 and negative 1 aren't going to factor this. So, I can use that previous work. Now, 3 did work, and there's a possibility that 3 might work again because maybe the multiplicity on this is greater than 1. So I might be smart to come back and to right now try 3 on this and see if I could get a 0. So I'm going to do it in a different color here just to kind of keep track of what's going on. And I'm peeling off these numbers. 1, 3, -3, and -9. So the 1 comes down, 3, 9, 27, 24, 72, and that's not 0. So I can, let's try -3. I can scratch +3 off the list. So let's try -3. Hey, and it works. I've got it. Okay. So this, I'm working with this one that I've highlighted in yellow. Don't throw away my previous work of the x minus 3. Now I look at this -3 and I write it in factored form as x plus 3. And I look here, remember this started out x cubed, so I know this 1 is 1x squared. And then I've got 0x minus 3. So I've got it down to a quadratic, because when I get it down to a quadratic, I know that if I can't factor it, the quadratic formula could always solve, because I set each one of these factors equal to 0 and solved it to try and find rational 0. So the list that they wanted, let's highlight, originally, before I crossed that out, it was this original list that they were wanting. Then I used a modified list of that to continue through the rest of the problem on this part of the original polynomial. All right, so when I solve this equation, if x minus 3 equals 0, then x would be 3. And if x plus 3 equals 0, x would be -3. And here, x squared is equal to 3, and x is equal to plus or minus square root of 3. But see, that's irrational. The directions said they wanted rational roots. So +3 and -3. Now, I can count these in the sense that I knew I had a degree 4, and if I found 1, 2, and the positive is 1 and the negative is another x-intercepts, I found all 4 x-intercepts. But what I was interested in, because the directions, was the rational numbers, the ones that you can write as a ratio of integers. So there's my answer for number 7, and I hope that helps.